To follow the idea of forecasting seasonal tropical cyclone activity, let's look at some of the unusual tropical cyclone seasons around the globe, just as examples. Starting with this in the Northeast Tropical Pacific. In 2006, the Eastern North Pacific seemed to constantly have tropical cyclones forming. The entire season from Aleda through Sergio is plotted here. So you can see that 2004 was nothing unusual other than a small 2006 was just I think a small warming near the dateline, no major El Nino, so you would expect maybe during El Nino you have reduced shear here and favorable cyclogenesis conditions in a composite sense, but that's not what was driving it here. Also in 2005-06, because we are switching hemispheres, we straddle the year here. Tracks of all 2005-2006 Australian region tropical cyclones, and here a satellite montage of severe tropical cyclones Glenda, Monica, and Larry. That's a nice, you can see the unusual pathways here, right? These three storms impacted Australia within a month, but only two storms were active at any time. This artificial image is obviously created to compare them. And again, you can see the Genesis region here and the Genesis region here, and how Australia is affected by activity on both sides. MJO activity is related here as well, in the sense the Indian Ocean part of the MJO either crosses the maritime continent across the equator, around the equator, or gets detoured, or gets weakened and stalls in the eastern Indian Ocean, or weakens over the maritime continents and reinvigorates on the western Pacific side, and so on and so forth. But almost all of them have downwelling Kelvin waves associated with them in the Indian Ocean. Those Kelvin waves become coastal Kelvin waves, and they create warm sea surface temperatures in this region, which interact with the Indonesian through flow coming through here. So this region is very special for fisheries and other things, as well as for cyclogenesis. Okay, so that's for 2005 and 6. 2006 and 7 in the South Indian Ocean tropical cyclones. This region is very active as well. This is also the Genesis region just north of here for MJOs, and many of the MJOs are triggered from extratropical influences over this region as well. So cyclogenesis has a relation in that sense as well. So the 2006-7 South Indian Ocean tropical cyclone season was extremely active. Madagascar in particular suffered severe impacts, although other parts of the of southern Africa did not go unscathed. So here is the IR image of tropical cyclones on 22nd February. So just one day, you can see how many are active over here. The train going across Madagascar here and across the Mozambique Channel into southern Africa. Okay, just examples, and let's look at a few examples of the northern hemisphere, a few more examples. Both 2004 and 2005 I will show on the next panel for the Atlantic hurricane season, were very active and became notorious for their multiple landfalls in the Caribbean, Central America, and North America. But were these seasons unprecedented? Statistics from 1933 hurricane season, this is the 1933 hurricane season, show that this was also an unusually active season. Further, the map of observed tracks from 1933 shows no tracks were recorded in the eastern third of the basin. Okay, so you can see an empty spot here. It's feasible that there were tracks in these regions that were missed. Track data and statistics are taken from this database. So since this is a long time ago, maybe the observation systems recons were not as solid or robust as now. Of course, there were no satellites, so something may be missed, but these are well recorded. So you can see that this was a very active season as well. So when you when we talked about decadal modulation and interannual modulation before, now this makes the point that the relation between interannual modes of variability and decadal modes of variability have to be considered carefully in terms of number of cyclones, storm days, wind speeds, and so on. So you may get a different answer depending on what you consider. 2004 North Pacific tropical cyclone here, 30 tropical cyclones including 16 typhoons and 5 super typhoons in the western North Pacific in 2004 ranked this as an active season even for this very active region. So this is already the highest activity, as we saw, about 30% of the global cyclones forming here. Even then this was more active than normal. Climatologically, the western North Pacific has 25 named systems, with 16 of these being typhoons or super typhoons. For Japan, this season was particularly devastating. 10 typhoons made landfalls in Japan that year. Many of these were either undergoing or having completed the extratropical transition. So they were all born here, survived as and evolved as tropical cyclones, and then transitioned to extratropical cyclones. Sorry, I misplaced this, so let's go back to this story and then compare the other North Atlantic seasons. Switch them in your mind. Nothing special happening anyways. So 2004 North Atlantic tropical cyclones, you can see the categories listed here and how they started: subtropical depression, extratropical storm, and so on and so forth. 2005 we said was a record season, and 2020 tied it in terms of the total number of named storms. They eventually, I think, ran out of names and started using Greek letters like epsilon, delta, zeta, and so on. So the expected number of names that are generated before the season were run out, so they had to make up names using Greek letters. That indicates how active the season was. And of course it's famous for Rita, Dennis, Katrina, Arlene, and so on and so forth. The region here in the southeastern US, Wilma, etc., got really hammered. Okay, so comparing the seasons of 2004, 5, and 1933, the North Atlantic hurricanes. Climatology, we expect 10 named storms, 4 tropical storms, 6 of them becoming hurricanes, and 1 to 2 becoming subtropical storms. 2004, there were 16 named storms, 5 tropical storms, 9 became hurricanes with 1 subtropical storm. 2005, monster year with 28 named storms, and they ran, I think they only make up 21 names if I'm not mistaken. So they made up 7 or 24 maybe, you can check it online. And then they used Greek letters. Tropical storms were 12, more than almost 3 times the climatology. Hurricanes, again, more than 2.5, almost 2.5 times expected. 15 and 1 subtropical storm. But 1933 was also pretty strong. 21 named storms, 11 tropical storms, 10 hurricanes, and no subtropical storms. The naming convention was different during this time, before 1960, so one has to be careful about that. But nonetheless, it doesn't change the story of how this year was also very active compared to what we expect climatologically. Okay. That's just examples of how unusual years happen, and they are not necessarily related to El Nino, La Nina. 2020 was a La Nina year, so it was very active, and 2005 I think was essentially a normal year, not a very special year.